Hi everyone, it's Tutor Fortune here. So in this video, I'm going to solve a question on organic chemistry, which involves a chiral center. Okay, so we are going to discuss what a chiral carbon is. Okay, then the second question is asking us um, to list. So we've been given a list of these molecules. So we are being asked to list those are some of the molecules with chiral centers, and then we identify those chiral centers. Okay, so I'm going to solve this question up to part E here. Okay, so if you want to access this other solution, you can simply subscribe with us. So you open your browser, or you can subscribe with us. Let me just show us. Let me just show you how you can subscribe. Okay. So you simply open your browser like that. Okay. When you open your browser, you have you type Discrete Learning Institute. You open like that. You have something like this. Then you go in the folders. You have folders for different courses. Okay, so you pay for a course of your choice. So in this case, let's say you pay for uh, chemistry. You can simply go in the folder written chemistry. Then you click the one, then general chemistry. Pick it like that. Then you can go to this folder if you wanted Toy sheet solutions, like the one we are solving is Toy sheet 6 for UNLAS organic chemistry. So you can simply go in that folder, retain Toy sheets and assessment. You go in it, you click there. Okay. Then when you open, wait for it to open. So let me just wait for it to open. Okay. Yeah. Yeah, so when it opens, you click the university. So the university for that one is UNLAS. You can go in UNLAS there. I open it like that. Then there are semesters. So that's for semester 2. I can easily go in that for the written semester 2. Then I choose. So do I want a written solution or recorded videos? So for recorded videos, you simply go in that folder, written recorded videos. You open like that. Then you find these two folders. You can go in the folder written July intake there. Open like that. Then there are these folders for the tutorial sheets for this semester. Okay, so you have the one written organic chemistry tutorial sheet 6. That's a tutorial sheet where you can find the solution for the whole tutorial sheet 6. Okay, so now let's go back to our business. We solve our question there. Okay, so let me go back. Okay. So yeah, so we have our question 1, which is saying what is a chiral carbon? Okay, so it's asking us to define what a chiral carbon is. Okay, so a chiral carbon is simply, so a chiral carbon is simply is a carbon which is attached to 4 different. So a chiral carbon is a carbon which is attached to 4 different atoms or groups. Okay, so you can say atoms or groups. Okay, that's what a chiral carbon is. Okay, so a chiral carbon is going to be a carbon which is attached to 4 different groups or atoms. Okay, so the main term there is you having 4 different groups or atoms attached to a carbon. Okay, so let me give you an example. Okay, let's have this. So I give you an example of 2 carbons. Let's say you have this carbon. Okay, you have this carbon. It's attached to hydrogen there. It's it's attached to a methyl group. Then it's attached to a halide, they say chlorine. Then it's attached to uh, they say an alcohol there. Okay, so these are 4 different atoms or groups attached to this carbon. Okay, so this carbon is a chiral carbon. But let's say you're having, so this is a chiral carbon. Let's say you're having a carbon, this is a carbon, which is attached to hydrogen. Let's say it's also attached to hydrogen, then it's attached to OH, then it's attached to a methyl. Okay, so you can clearly see here, you have only 3 different groups or atoms attached to this carbon, because this hydrogen and this hydrogen, they are the same. So this carbon is not a chiral carbon. Okay, so now we can go to part 10 there, which is saying some of the molecules listed here have a chiral center, some do not. Okay, so identify those with chiral centers. So let's identify some of the carbons with chiral centers. Let's start with our A here. So for us to identify the chiral center in these molecules, it's best to come up with their structure. Okay, so also the videos for how to write the structures for your hydrocarbons. We did that in the tutorial sheet, so you can access them on the website. Also, we have this here. So let's write the structure for this molecule. Okay, so we have 2 propane there. Okay, so this propane is a parent name. So propane, it's a 3 carbon molecule. So 3 carbon molecule. Now they're saying at position number 2 you have a fluorine. Okay, position number 2 you have a fluorine attached to it. Okay, then you are having hydrogen here, hydrogen for the first one, it's a methyl, hydrogen there. You have hydrogen here, you have hydrogen there, hydrogen here, hydrogen here. So now, do we have a chiral carbon in this molecule? Okay, so let's check our carbon number 1. Is it a chiral carbon? No. So you have 3 atoms here, hydrogen atoms, which are same atoms attached to this carbon. So this is not a chiral carbon. Let's go to the next one. So the next one, you have a fluorine. Okay, a fluorine attached to this carbon, then hydrogen attached to this carbon. Yes, but you're having 2 methyl groups. These are methyl groups, which are same groups attached to it. So our carbon number 2 is not a chiral carbon. Okay, then we have this one, the last one, same with the first one. So not a chiral carbon there. Okay, so here we don't have a chiral carbon in this molecule. Okay, so our part A, we have 0 chiral carbons there. Okay, so you can simply say we have 0 chiral carbon in that molecule, part A. Let's go to part B. Okay, so part B, you're having 2 methyl butane. Okay, so you have 2 methyl butane. Okay, so butane is a 6 carbon molecule. Okay, a 4. Okay, so but is a 4 carbon molecule. So we have 1, 2, 3, 4 there. Okay, then to this butane, we have in at position number 2, we have a methyl group. Okay, so here at position number 2, we have a methyl group. Okay, so we have hydrogen there, hydrogen here, hydrogen there, then we have hydrogen here, another hydrogen there, hydrogen here. Okay, so this is our structure for methyl, 2-methyl butane there. Okay, now do we have any chiral carbon here? Let's start with carbon number 1. Carbon number 1 definitely is not a chiral carbon. You have a hydrogen, which is the same as this hydrogen, which is the same as this hydrogen. So it's only having 2 different groups attached to this carbon, okay, which are hydrogen, 3 hydrogens, and this methyl group, this hydrocarbon chain here. So this is not a chiral carbon. Let's go to the second one, okay? So this one is attached to a hydrogen there and a methyl group on top. And also here we have a methyl group there. Okay, so 2 methyl groups. So this is not a chiral carbon as well. Okay. Then let's go to the next one. It's having 2 hydrogens attached to it, which are same atoms. It's not a chiral carbon. Same with the last one. It's having 3 hydrogens, which are same atoms attached to it. So it's not a chiral carbon as well. Okay. So you can say even our part B, we don't have any chiral carbon there. Okay. So we have 0 chiral carbon in part B as well. Okay. So 0 chiral carbon there. Okay. So let's go to part C. Let's see what we have in part C. We have 2 chloro butane. Okay. So same butane, 4 carbon molecule. Okay. So we have our 4 carbon molecule. But is 4. Okay. We have meth is 1. A is 2. So when you say a prop is 3, then we have but is 4. Okay. So that's why we're having a 4 carbon molecule there. Okay. Then at position number 2 here, these 2 indicated. At position number 2, you have a chlorine attached to this carbon. This carbon number 2, you have a chlorine attached to it. Okay. Then here, you have a methyl group. Okay. You have a hydrogen on top there. Here, we have a hydrogen. Here, we have a hydrogen. Here, we have a hydrogen. Okay. So let's check if we have any of this carbon as chiral carbon. Okay. So we start with the first one. This is not a chiral carbon. We have hydrogen, hydrogen, hydrogen. Those are same atoms. Let's go to the second one. This one here. Okay. So it is attached to hydrogen. It is attached to chlorine. These are 2 different atoms. Okay. It is attached to this group. This is an ethyl group. You notice that this is an ethyl group. This is CH2CH3. CH2CH3, which is an ethyl group. Okay. Then you have this side is having a methyl group. This is a methyl group. So these groups are different, are 2 different groups. Okay. So it's having 4 different atoms and groups attached to it. So this carbon number 2 here is a chiral carbon. So this one is a chiral carbon. This is not a chiral carbon as well. We have 2 hydrogens. Same with this one. We have 3 hydrogens attached to it. Okay. So here we've identified that this carbon, the carbon number 2, is a chiral carbon there. Okay. So our part C, we've identified carbon number 2 to be a chiral carbon. Okay. So here we have 0 chiral carbon. Okay. So for part C, you can see there carbon number 2 is a chiral carbon. Okay. So let's go to D before I do the last one. Okay. So for D, we're having a butano. So this butano, this one here, it means that at position number 1, you have an alcohol. Okay. Then this alcohol has high purity amongst the substituent. So it will carry a parent name. Okay. So this O means that you have an alcohol, which is the parent name, and it's at position number 1. Okay. So you can simply write still a but. So say 4 carbon atom, 4 carbon molecule like this. Okay. Then at position number 1, you have an alcohol, which is the functional group. Okay. So meaning you can have hydrogen here and another hydrogen there. Okay. You have hydrogen here, another hydrogen here, hydrogen here, and another hydrogen there. Okay. Then you have a methyl there. Okay. So let's identify if you are having any chiral carbon. Let's start with the first one. The first one is attached to hydrogen, and you have an alcohol group and a propyl group this side. Okay. So this is not a functional group in that you're having 2 hydrogen. These are same atoms. So this is not a chiral carbon. Okay. Then let's go to the second one. Okay. So the second one, you're having, okay, so we are the methyl at position number 2. Okay. So let's just put that methyl at position number 2. Okay. So having a methyl at position number 2, I didn't consider it. So we have a methyl at position number 2. Okay, so let's check if it's a chiral carbon. So here we have this hydrogen atom attached to this carbon. You have a methyl group attached to this carbon. You have an ethyl group attached to this carbon. And you have this group attached to this carbon. This is not a methyl group. It's an alcohol. Okay, so these are 4 different groups attached to this carbon. So there you can clearly see that also here carbon number 2 is a chiral carbon. These others are not chiral carbons because you can clearly see you have 2 hydrogens attached to this carbon and 3 hydrogens attached to those the other carbon, which are same atoms. Okay, so those are not chiral carbons. So for D, we've seen that our carbon number 2 is also a chiral carbon. Okay, so let's do the last one. Okay, so for part E, our NDA said the other solutions, you can access them on the website. So for part E, there have a trans. Okay, so remember what I said on the if you go back in the website, I explained what a trans and a cis is. Okay, so here we have a trans butene. Okay, so these two, it means that you have a double bond. Okay, butene, the teen there means that it's an alkene. So you're having a double bond. Okay, at position number 2. So you have this carbon number 1. You have 4 carbons, it's a but. Then at position number 2, this carbon number 1, carbon number 2, we have a double bond there. Okay. Then you're having hydrogen here. Hydrogen here. Okay. Then you're having hydrogen here. Okay. Also, here you're having hydrogen. That's how a trans is going to look like. So a trans is going to have atoms on the opposite side. So you can see this for this carbon at a double bond. For this carbon, the atom is down. Then for the other carbon, the atom is on top. Okay, so that's a trans arrangement. Okay, so in this case, let's see if you're having any carbon which is a chiral carbon. Okay, so you have these methyl groups here. So for carbon number 1, this is not a chiral carbon. It's having 3 hydrogens attached to it. So it's not a chiral carbon. Let's go to carbon number 2. So this carbon number 2 is having a double bond. Okay. So for a double bond carbon, okay, most of the time it's going to be sp2 hybridized. Okay. So this is sp2 hybridized. You're having a double bond. Same with the other one. This one is also sp2 hybridized. Okay. For sp2 hybridized carbon and sp hybridized carbon, you will never have a chiral carbon from these two. Okay. For an sp2, you notice that it is attached most of the time to 3 different groups. Okay. So you can never have 4 different groups attached to this one. Same with the other one. Okay. For sp, you find that you have a triple bond here. So this carbon will only be attached to 2 different atoms. So it can never be a chiral carbon. So for these ones, you never find a chiral carbon. So here, you don't have a chiral carbon. This is not a chiral carbon. This is not a chiral carbon because of those double bonds. Okay. Definitely even here, this one is not a chiral carbon. So for the last part as well, we don't have any chiral carbon in that molecule. Okay. So we have 0 chiral carbon. Okay. So that's where I'll end for this tutorial. But if you want to access the other solutions, you can subscribe the way I've showed you when starting the video. Okay, so the link for subscribing, you'll find it on the description of this video. Okay, so I end here.